Today we're going to talk about reorder routes to make all paths lead to city 0. So the problem says we should be able to reach from any of this node to 0. Okay. And if there is no path available, then what we have to do is like we'll have to kind of count the number of changes which we have to make to satisfy this property, which is like we should be able to reach destination 0 from any other node. Okay, that's the whole point we are talking about. How do we do it? Okay, so first what we have to do is if take 0 and check is that can I reach from 1 to 0, 4 to 0. In this particular case, there is a connection from 4 to 0, but there is no connection from 1 to 0. Then I have to change this. And then take this. Can I like take 1 and then find out the neighbors? Neighbors, in this particular case, 3 is the only neighbor. Is there any route from 3 to 1? Okay, if it is there, then 3 can reach 0 because there is already path we constructed from 1 to 0, right? So then there is no, then you kind of create one more path, totally 2 now. This is 1, this is 2. Then move on to 3. Find out the neighbors of 3. In this particular case, 2 is the only neighbor and there is an already path available. We don't need to make any changes. And come back to 0 and then see from 4, can I reach 0? Yeah, you can reach 0. There is already a directed edge. And then go to 4 and then explore their neighbors. In this particular case, the neighbor is 5. And from 5, we can't reach 4. Right? Since 5, we can't reach 4, we have to make one more changes here. There are 3 changes we have to make. Finally, the answer what we have to return is 3. Okay. So if you look at this, it's actually, we can use either depth first search or breadth first search. If you use depth first search, keep exploring. To explore this, we have to construct an adjacency list with the property called undirected graph. Like in this case, it's a directed graph. You constructed a graph which undirected property in nature and start exploring. When you start exploring, you have a set which actually nothing but the connection edge. We keep an edges and the 0, 1 is 1. 1, 3 is another one, 2, 3 is 1, 4, 0, and 4, 5. Okay, this is a set you construct prepare. Whenever you go whenever you explore any node's neighbor, in this particular case 0, exploring the neighbor 1 and 4, check from 1 to 0 is there any connection available in this set. Okay, there is no connection. There is a connection 0 to 1, but there is no connection from 1 to 1 because we have to find out is there any connection from 1 to 0. We have already a connection 0 to 1, but do we have any connection from 1 to 0, right? If there is a connection from 1 to 0, then we don't need to change. There is a path already available. Then we start exploring the other nodes. In this particular case, there is no connection from 1 to 0. Then keep a count variable and then increment it by 1. Okay, by 1. Increment it by 1. And then move on to 1 and check. Then now what we have to find out is like once you move the current node to 1, we have to check is there any connection like 3, 1. Is there a connection available in this set? 3, 1. No, there is no 3, 1 available. Then what we have to do, increment this to by 1. Okay, so totally now 2. And then now move the current node to 3 and then check 2, 3. Is there any connection available 2, 3 in this set? Yes, 2, 3 is available. Then don't count and move on to the other one. So this like 4. Is there any connection from 4 to 0? Yes, 4 to 0 is there. Then don't count and then move on to the current node to 4. Okay, on to current node 4. From check whether this is actually the source, this is destination source. Like, is there any connection 5, 4? Is there any connection 5, no? There is a connection from 4 to 5, but there is no connection from 5 to 4. Then increment this to 3, and this is how we find out finally return this result. So if you see, the 2 things we have to take care. One is like create an hash or set using these connections, and construct an adjacent list. Here the graph is directed graph, but you construct a undirect graph adjacency list, and then using the adjacency list start exploring the path. Whenever you start exploring, try to find out, you have to just reverse it, like instead of like 0 to 1, we just have to reverse it. Is there any connection from 1 to 0? If that is not present in this list, in this set, then you increment the count, and finally that's going to be the result.